Hello and welcome to another video of Learn with Mr. Masala. Today I am teaching standard deviation, and if you notice some background music, it's my son that he is with me right now, and he might disturb in some way or form. But yeah, please do not get distracted, and let's go and talk about standard deviation. We can find the dispersion of above data from various methods, but standard deviation is the most popular and useful measures of dispersion. So whatever the dispersion method that we used previously, that was a mean, but standard deviation is more popular and is very useful measures of dispersion used in practice. It removes the drawback presented in other measures of dispersion. It gives the uniform, correct and stable results. The standard deviation is defined as the positive square of the mean of the square of deviation from the arithmetic mean. It is also known as the root mean square deviation. It is denoted by the letter this one is called sigma. It was first introduced by Carl Pearson in 1832. Standard deviation is the best measures of dispersion because first one, its value is based on the observation, and second one, the deviation of each item is taken from mean, and third one, all algebraic signs are also considered. The smaller value of deviation, standard deviation means a high degree of uniformity of the observation as well as the homogeneity of the city. So we opt to get the smaller value in standard deviation. So calculation is simple. First we need to find the mean, then find the assume mean method or shortcut method, step deviation method and direct method. So there are different kinds of method which you can do. So whatever that is, we need to find the mean first. That's what I think. Doing that, we have different kinds of method. Like for actual mean method, this is more practical, I think. This is, so we have this value be the mean value of corresponding classes x1 x2. So we have these classes, and m1 m2 m3 are the mean value of those classes, and f and f are the respective frequency. Now x is the actual mean. So what we do is standard deviation equal to root under the frequency, total frequency, and m minus x, this is mean, square divided by number of items. So in this way we get the final value. Yes. Look, allergy huncha hai babu, please don't do that. Then what we do is step is to find the midpoint from each class interval, we can do that. This will find the this actual mean of whole data, then to find the difference between each mid value and mean. So mean ra त्यो अगाडिको mid value point को चाहिँ difference निकाल्ने, त्यो चाहिँ d भयो. Now squaring the d, then squaring and square d into frequency, some frequency, and this is our standard deviation. We can use other methods like what we can do is we can assume this mean. If we don't have proper data, we can assume this mean value and we can solve the problems, So what we do here is this method is called shortcut method to calculate the standard deviation. Actual mean method is difficult and takes more time. In assume mean method, by supposing number as mean, we can calculate the standard deviation. Let m1 m2 m3 yes mn be the midpoint of the class interval f1 f2 f3 and fn sum. Alright, so be their corresponding frequency and a be the assume mean. Yes, so a like assume mean we can find the value. Yes beta. Now what we do is consider assume mean A from mid value, then take the standard deviation of each mean A and denote it by D, each, and take deviation of each item from A. And denote by D, then multiply each deviation D by the corresponding frequency F and D square निकाल्ने okay. So A as you भने A minus D गरेर चाहिँ भ्यालुहरु निकाल ए हैन A minus त्यसको के निकाल्ने mid value नै A भयो right, and take the deviation of each item from A and A. Now A is हाम्रो चाहिँ के भयो mean भयो. Now हरेक सँग चाहिँ त्यो माइनस गर्ने, माइनस गरेर चाहिँ त्यो चाहिँ D हुन्छ right. So D को भ्यालु लिएर चाहिँ हामीले यसरी फर्मुला लेख्यो भने हुन्छ. Step deviation, this is something else. Step deviation method, mean value लियो, mid value लियो, त्यो गर्यो, assume यानी assume छ. What is difference here is m minus a गर्यो, no problem, and d dash निकाल्न चाहिँ what we do is m minus a divided by c गरिन्छ रहेछ. What is c? What is c here? Okay, so C, we introduce a C. I is a class interval. So different class interval ma hamle lin sakincha, but I have no clue about the C because nowhere it is mentioned. D dash is equal to D by C and m minus a equal to C. I think this is not C, this is I, maybe I, you know. So finally direct method is like just take this value m and x1 standard deviation is f m square by n. So m1 and m2 be the mid values of corresponding classes 80 and frequency. सबको सम लिने गर्ने, सिम्पल सबको मिड भ्यालु लिने गर्ने, राइट. यहाँ चाहिँ के हुन्थ्यो भने वी फाइन्ड समथिङ कल्ड डी. टी चाहिँ कसरी एउटा त्यसको मिन लिएर चाहिँ एन्ड एक्चुअल मिन नलिकन गरेको त्यसमा चाहिँ डाइरेक्ट टीटीको के के ल्याब बाबुको ल्याब त खै बाबुको ल्याब त यो हो okay. So in this way we gotta learn from it. Look how the actual mean is taken. Look at this example, and if you have any problem in that, please let us know. Look how the mid value is taken and how the D's actual mean is taken from there and how it is done, and here how it is assumed. So direct method is also easy. In direct method we don't evaluate D, but we directly find FM with that mid value, and FM and m square like that. Assume mean like we assume some data, like what is m a, we assume like 35 and we do the solve problem. Again we assume here, but we find okay that was D by IA, and that's what I thought. C and I. What is I? I is the interval. So what is the class interval? 10. So we take 10. So we'll do another variation in next class. Thank you for watching. Bye bye. Take care.